are for a circle, a radius, and a diameter. But then you're going to notice that there are more than just 3 blanks to fill in, because some of the things that are within the definition need to be addressed in our image. So a circle is a figure drawn in which all points are equidistant from a given point called the center. The center of a circle is a very important part of the circle. All right, and so that C, that is pointing at the center of the circle. All right, and then it separates a plane into 3 sections: an interior, an exterior, and the circle itself. So we have, when we draw a circle, we create an area on the inside of the circle, we create space on the outside of the circle, and then we talk about things that are on the circle. So inside the circle, we would call this point I on the interior. So this is a point in the interior. All right, and so that point is considered a point inside the circle, in the interior of the circle. E is an example of a point in the exterior of the circle. And then we don't in this picture have any points on the circle itself, but if there was a point, say right here, that would be a point on the circle. All right? And then we have the term radius, and this is a term that I do believe you all are familiar with. The radius of the circle is from the center to an end point. So the radius is represented by this line here. That is the radius. And the plural of radius is radii. So if you see that written somewhere, radii is plural for radius. And then the diameter. The diameter is the distance all the way across the circle through the center. So this is the diameter. Again, some of this not new to you. Some of it is stuff you already know, but we will get to some things that are new to you. All right. So once we have identified those things, then we can name parts of the circle. So if we're going to name this circle, we always name a circle using its center. So this is circle. So it's a circle with a dot in the middle. Circle Q. We always name a circle by its center. And then we're going to name all of the radii. So again, the radius is from the center to a side. So Q to R is not a radius because R is not on the side of the circle, right? So the first radius we see is QP. Another radius is QT. And then is QS or QX a radius? No, because that extends beyond the side. It does not land on the side. If the S was on the side of the circle, then yes, it would be. If the X was on the side of the circle, it would be. But because it is not, those are the only two. All right, and then what is the length of all of the radius? If the length of one radius is 16, then the length of all of them is 16, because a circle is again a shape drawn where the sides are equidistant from the center. So then what would the length of the diameter be if the radius is 16? How are the radius and diameter related to one another?
The radius is half of diameter.
Radius is half of diameter, so if we know a radius, to get diameter we just double it, which would be 32. And then we're going to name all of the points on the interior of the circle. Then the points on the interior are Q, R, and S. P and T are on the edge of the circle. They are not considered interior or exterior. They are on the circle. And then the exterior point is point X and only X. Then example 2, directions are given here at the bottom. I don't know why I didn't pay attention before I copied these. So example 2 wants us to calculate a radius or diameter. So again, just based on what we know about the radius being half of the diameter. And if you need, in order to remember that, you can write this. If the radius is going to be equal to the diameter times 2, If you have a diameter, it will be equal to, or to get diameter, excuse me, nope, that's backwards. Diameter divided by 2. If you have a diameter, it is 2 times the radius. So if you need a radius and you have the diameter, you divide by 2. If you need the diameter and have the radius, you multiply by 2. So here we have a radius of 27. So I have a radius, right? And I want a diameter. So I'm going to multiply the radius by 2, and 27 times 2 is
54.
54. If I have a diameter of 12, diameter goes all the way across the circle, so the radius would be half of that. So the radius would be 6. Again, if the diameter going all the way across the circle is 18.6, then the radius would be?
9.3.
Because 18.6 divided by 2 is 9.3. So again, that nothing new to you. That should be a review of, I don't know, 7th or 8th grade. All right, and then the formulas for circumference and area of a circle. There are 2 formulas for circumference depending on what information you're given. So circumference is equal to 2 pi times the radius. If you're given a radius, you can use that formula. If you're given the diameter, you can just multiply pi times diameter. Can someone tell me why these 2 things are the same?
Because the radius is 2 times.
If you multiply the radius times 2, you get the diameter. If you multiply the radius times 2, you get the diameter. That is why these are the same. All right, because if you multiply the radius times 2, you get diameter. So the only reason there are 2 of them is so that you don't have to calculate a diameter or a radius if you're given one or the other. But the formula for area of a circle is pi times radius squared, which is not the same as the diameter, right? Or it's not the same as multiplying radius times 2. Times 2 means times 2. Squared means a number times itself. So there is a difference. This is not the same as either of those. And so for area, you do have to have radius. So if you're given diameter, you would have to find radius in order to use the formula. All right, and so if, in example 3, if we have a circle that is inside a quadrilateral, and that circle touches that quadrilateral on all 4 sides, what shape is the quadrilateral? It is a square. And so we have a quadrilateral with a circle inscribed inside, and it touches on all 4 sides. Therefore, the quadrilateral is a square because we know that circles are the same distance all the way across, right? So, do we know the diameter of this circle?
Yes.
If I draw a diameter, remember a diameter goes through the center, it has to be what?
10.
It must be 10 because that is a square, and so that is 10 millimeters. And so our diameter is 10. I need to find circumference and area, so I need to know the radius. So let's go ahead and find our radius. If the diameter is 10, the radius is
5.
half of that, 5. And now we have all of the variables to go into our equations. Pi, there is a key on your calculator, but I just want you to approximate it as 3.14. Please do not use the pi key. And it will matter because as you multiply, if you use the pi key and you're multiplying by a big number, the difference in the answer will be sizable. So make sure you're using 3.14 for pi, not the pi key. And so to find circumference, we multiply pi times diameter, so 3.14 times the diameter 10. And what is 3.14 times 10? 31.4. And then to find area, the formula is pi times the radius, which is 5, squared. And so 3.14 times 5 squared. Jack, are you with me? Jack. So what is 3.14 times 5 squared? Anyone?
78.5.
And that is millimeters squared because it's area. All right, in example 3, we're going to find the circumference and the area of circle P. And what you notice is you have a circle with a triangle inscribed inside. It's a right triangle, and the the hypotenuse goes through the center of the circle So that hypotenuse is representing what of the circle? The diameter of the circle. And so the hypotenuse is the diameter, and I want to find the diameter. That's the first step in solving for circumference of circle. And so what can I use? What theorem can I use? I can use Pythagorean theorem to find that length. And so Pythagorean theorem, if you're finding hypotenuse, is a squared plus b squared. So a squared, 30 squared plus 16 squared. And then if you put the square root sign around it in your calculator first, it will give you that answer straight away. And so if you do that symbol and then put those in, what does the diameter equal? 34. Most of the time it's not going to be a whole number, just FYI. And so then if the diameter is 34, what do I do to find the radius? Divide by 2. 34 divided by 2 is 17. And now I am ready to find circumference and area. Remember, using pi is approximately 3.14. So circumference, that formula is pi 3.14 times the diameter, which we found to be 34. And so 3.14 times 34 is
106.76.
And there are no units here, so I'm just going to write u in for units. And then to find area, it's pi times radius squared. So 3.14 times the radius we found to be 17. We'll square that. So put that in your calculator. What is 3.14 times 17 squared?
907.46.
Say again?
907.46.
90746, and that's units squared. Again, the example 5 directions, find the circumference and area of the triangle. And so everyone okay with that? We all got that? All right, and so this is a square inscribed inside a circle, a little bit different than our circle inscribed in our square. And so here they tell us it's a square by showing us those little hash marks. And then I want to remind you of something. So that diagonal that is cut into the corner of that square is representing what of the circle?
Diameter.
It is the diameter. So if I find that side, then that is the diameter. We can use Pythagorean theorem because we know this is 8 and that is 8, yes? But do you also remember that the 45, 45, 90? A square, when you cut a diagonal, cuts those 90s into 45, 45. So if this is 8 and this is 8, the ratio is x square roots of 2. And so you just stick an 8 in there, and so the diameter is equal to 8 square roots of 2. But if you don't like those and you can't remember that and you don't ever want to use that, if you use the Pythagorean theorem, it is 8 squared plus 8 squared, and you take the square root of that, and you will get the same answer for both of these. So I want you to put both of them in your notes, just in case you decide that you want to try to use that. And I don't have a calculator with me. So 8 square roots of 2, somebody do that. And then somebody do the square root of 8 squared plus 8 squared. And what do you get for both? 11.31 here and 11.31 there. And there's other digits, but we're just going to round to 2 digits. So you get the same answer either way you go. I do think, though, that this is going to be beneficial because when we get into cylinders and finding volume and area of cylinders, this is going to be helpful. That ratio is going to be helpful. All right, and so if our diameter is 11.31, what is our radius? 6. Let's round to 6.6. That's the decimal I've been rounding to today. So the radius, let's use 5.66. And so now can we find circumference? We multiply pi times diameter. So 3.14 times 11.31. And we get
35.51.
And again, no units, so we'll just put units. And then to find area, it's pi times the radius, 5.66 squared. So we put that in our calculator. And we get 100.59. And that would be units squared. All right, I took off some examples, which is why there's blank space there. It might be a good idea to write Pythagorean theorem in there. It might be a good idea to write your 45, 45, 90 triangle theorem there. But the back is terms that we need to make sure that we understand. And then these terms we will use more when we get into the next parts of this unit. So a chord is a segment whose endpoints are on the circle. The diameter is considered a chord. It's the longest chord. So this, because it's on the sides of that line stop on the edge of the circle, that is considered a chord. A secant is a line array that intersects a circle at 2 points, and then it goes beyond the circle. So this line here is representative of a secant. And then a tangent. A tangent is a line segment array that intersects the circle in exactly 1 point, and then it extends on the outside of the circle. And so this here is tangent, and then the line at the top is pointing at the point at which it intersects, and that is the point of tangency. Have you ever heard someone use the expression they went off on a tangent? Never heard that expression? Well, so if you imagine if you're going along in a circle and you go off on a tangent, you take off out into space somewhere, right? You like hurl yourself off. That's kind of where that, I think, term came from. But also I had kind of hoped, or I wish that we had been further along than we are, because NASA, when they calculate the distance that the Earth is from the moon, guess what they use? Tangents. So there is application for this in the real world. Beyond just space, but there is application for that. All right, so we can then use that vocabulary to name the points and lines of this circle. So the center of this circle is that point. The center is O. Let's name all the radii. Matthew, can you name one radii? From O to what letter?
I think N.
N. O to N is a radius. Very good. Name another one. Faith.
O to R.
O to R. Name another one. Carlos. There's not a Carlos in this room. Michael. I'm sorry, what? N?
N.
O to M, yes. All right, and so so those are all of them. Can we name others? We can go O to what? O to T. That would be a radius. Ava, we could also go O to Q. That would be another radius. So of the points that are on our circle, those would also be radius. We're not going to name them, but you can. There are others. And then are there infinite number of radii? Could I just keep drawing them? Yes. All right, and so then all the chords. What is a chord? A chord goes from one edge to another. And so is this MT a chord? It is. It's also, though, a secant because it goes beyond, but it is also a chord. And that looks like that. Nope, that's a segment. Sorry. And then another chord, remember the diameter counts as a chord. It goes from one side to another. It goes through the center, but it is considered a chord. So MN. And I do believe that is all of the chords. So then a secant, it goes through the circle, and then it goes beyond, is a ray or a line that intersects and goes beyond. So a secant is also MT. So MT is both a chord, considered a chord, and a secant. That's not always true. Not all chords are secants, but secants are chords. All right, and then what is the diameter of this circle? Blakely? MN. And then there is only one tangent. What is the tangent, Layla? PS. And then what is the point of tangency? Hillary?
Q.
Q. Questions about that? All right, your assignment today is going to be part vocabulary and then part finding circumference and area by first finding diameter and radius. Yes, ma'am. Let me get this passed out. And did your first period teacher give you a pass? Jack. Do you need to go to the learning lab so you can stay awake? All right, so the front, 1 through 7, you are using the vocabulary. Actually, 1 through 6, you're using the vocabulary, and then 7 and 8, you're determining a diameter or a radius. So the formulas are here. I've typed those on there for you. The Pythagorean theorem I have given you. 9 and 10 are just finding radius and diameter given the other. So either multiply by 2 or divide by 2. And then 11 through 17 are all finding the diameter so that you can calculate circumference and area. So again, using Pythagorean theorem, you can use Pythagorean theorem on all. Number 12, you could use the special right triangle, the 45, 45, 90, but the rest of them use Pythagorean theorem first to find the diameter, and then from there find the radius, and from there find circumference and area. All right, so you have the remainder of the period to work. Your notes are going to be helpful. Please be sure you are working.